All right, so far we've had a bunch of different kinds of spectroscopies that we first found out so far. We've talked about mass spectroscopy, where we ionize atoms and look for their deflection, and that helps us determine the mass and abundance of isotopes of an element. We've talked about atomic emission spectroscopy. This is where you excite electrons with heat or light, put them through a prism, and then let them return to ground state, producing spectral lines. And that lets us determine the identity of atoms in a gas. Last unit, we learned about photoelectron spectroscopy, emission spectroscopy. That's where we take electrons that are part of a metal and we bombard them with photons, and we see the energy of the electrons that pop off. And when we do that, that's essentially giving us ionization energies, so that helps us determine electron configurations and identities of atoms. So today, we're going to introduce a new one for you. This is infrared spectroscopy. Okay, and what infrared spectroscopy answers for us is the question of how do we know what kinds of bonds are in a molecule? All right, so here's what happens in infrared spectroscopy. When infrared molecule absorbs infrared spectroscopy, or infrared radiation, so light in the infrared range, it causes the bonds in the molecule to bend and stretch. You get vibrations, and those vibrations then create specific frequencies that come off, or that we can measure, and specific frequencies cause specific kinds of bonds to vibrate in specific ways. All right, so you can understand a little bit more about what causes the bend, or what the bending and stretching of bonds looks like. There's a small video in Schoology that would normally be right here, but I'm going to have you pop out for a second, go watch that, you'll see that. And then there is a second video that's a little bit longer that does show how infrared spectroscopy causes bonds to vibrate in specific ways. So how exactly does it work? Okay, well, you have a source of infrared light and you send it through whatever sample it is you're trying to look at, so the chemical you're trying to analyze, and we also send that same infrared sample or light through a reference place, okay? And then what happens is we change the infrared frequency, and eventually at some place along the way, the molecules that are in the sample will start to absorb some of that infrared energy, causing them to vibrate. Well, that means that the infrared energy that comes through the sample is going to be less, okay, especially compared to the reference. And so you can figure out what are the particular frequencies of infrared that are causing this sample's bonds to vibrate. Once you have that, we can understand better and better how specific atoms or how specific bonds cause that change in infrared radiation. All right. If we map that out, then we can start seeing that different kinds of bonds absorb infrared radiation at different frequencies. Okay, and they also absorb them different amounts. So sometimes they absorb them very strongly, and sometimes they absorb very weakly. Sometimes it's broadly, so you get the absorption over a wider range of frequencies. Sometimes it's very narrow. It happens specifically in one particular way. So if we compare an infrared spectrum to a key that looks like this, we can figure out what kinds of bonds are in my molecule. All right? So in the end, you get a graph that looks something like this, and you go ahead and you look for where these peaks are, these downward peaks. Okay? And each of those peaks is going to correspond to a specific kind of bond. So this peak here, for example, that happens at a wave number of 2971 corresponds to oxygen and hydrogen stretching action and carbon and hydrogen stretching action. Okay? A peak at 1721, that's caused by a carbon-oxygen double bond stretching. Okay? So we don't usually use this to determine entire structures, just parts and bonds that are inside it. Okay, this would be a narrow peak. This would be a broader peak. This would be a stronger peak. These would be medium or weaker peaks. Okay, Here's another infrared spectrum. Kind of look at it, look at the labels and everything about it. What's a way that you might use infrared spectroscopy? You'll notice that this is methamphetamine, or meth, right? So that's an amount of a drug amount. And so if you wanted to detect whether there was methamphetamine in someone's system, you could take a sample of their blood or something like that, run it through infrared spectroscopy, and if you got this signature, you would say, oh yeah, this person has meth in their system. Fun!